Good morning, this is your Stats Sensei, Mr. Spensei, and this is Death Packet, Unit 3A, Classical Probability, and these will be problems 41 through 50. So Joe and Matthew plan to visit a bookstore. Based on their previous visits to the bookstore, the probability distributions of the number of books they will purchase are given below. Assuming that Joe and Matthew make their decisions independently, that's important. What is the probability that they will purchase no books on this visit to the bookstore? So the probability that Joe will buy no books is 0.50. Probability that Matthew will buy no books is 0.25. Well, remember, if they're independent, we can go the probability of A and B equals the probability of A times the probability of B. So in this case, because they're independent, we can multiply our probabilities. So 0.50 times 0.25 equals 0.125. So our answer is B. According to a poll, only 8% of the public say they trust Congress. In a simple random sample of 10 people, what's the probability that at least one person uh, trusts Congress? All right, so first off, that means we have 0, 1, 2, 3, 4, dot, 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 all the way to 10. And at least would mean we're looking for the probability that X is greater than 1. Well, that's very complicated to figure those combinations. So I could do 1 minus the probability that no one trusts Congress. All right. So, um, first off, the probability that someone doesn't trust Congress is 0.92. So in this case, I'm going to have 10 blanks. I'm going to go 1 minus those 10 blanks. Now, I didn't draw 10 blanks, but 0.92 doesn't trust, doesn't trust, doesn't trust. So 1 minus 0.92 to the 10th power. So in this case, 1 minus 0.92 raised to the 10th power, and I get 0.565. So my closest answer is this. And by the way, the probability that is 0.92 raised to the 10th, that's the probability that no one trusts Congress. And this is the probability that at least one. All right. That 0.434, like I said, 0.92 to the 10th, that's the probability that all 10 don't trust Congress. 1 minus that probability gives me 0.566, which is the probability of at least one. All right, it's estimated that 30% of all cars parked in a metered lot outside City Hall receive tickets for meter violations. In a random sample of 5 cars, what's the probability that at least one receives a parking ticket? So once again, 0, 1, 2, 3, 4, 5. We want the probability that X is greater than or equal to 1. So this is what we're looking for. Again, that's very difficult to compute, but we can do 1 minus the probability that no one gets a ticket. Well, what's the probability you don't get a ticket? 0.7. So really it's 0.7 to the 5th power, and that'd be the probability that no one gets a ticket. But we didn't want that. We wanted at least one, so we go 1 minus that. So 1 minus 0.7 to the 5th power is B. All right, continuing the same theme. It's estimated that 20% of all drivers do not signal when changing lanes. That means 80% do. In a random sample of 4 drivers, what's the probability at least one doesn't? So we have 0, 1, 2, 3, 4, and we're interested in that group. So we want the probability that X is greater than or equal to 1. But I can do 1 minus the probability of 0 and accomplish the same thing. So what's the probability that someone doesn't signal? 0.8. I mean, these are the ones that signal. Signal, 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 signal. All right, so that's the probability that all of them signal. And 1 minus that is a probability that at least one did not. So 1 minus 0.8 to the fourth power. All right, continuing on. Number 45. A company bids on 3 independent contracts with a probability of the contracts 0.1, 0.25, and 0.3. What's the probability of winning at least one? So we can win 0 contracts, 1 contract, 2 contracts, or 3 contracts. So this is what we're interested in. We're in the probability of X greater than or equal to 1. And since it's an at least, we're going to want to do 1 minus the probability that they don't win a contract. Well, the probability of not winning the first one is 0.1, 1 minus 0.1, which is 0.9. The probability of not winning the second one is 0.25. So this is 0.75 is the probability of not winning. And the probability of not winning the third one is 0.7. So that's the probability of not winning any of them. That's the probability of winning 0. And 1 minus the probability of winning 0 is what we're looking for. So 0.9 times 0.75 times 0.7, you won 0 contracts. That's the 0 contracts, but we want 1 minus that. And 1 minus gives us the probability of at least 1. Is there home field advantage in professional baseball games? Emotional support from the fans and familiarity with the field seem to make a difference as the home team has won in approximately 5/9 of the World Series games. Assuming this probability is constant and games are independent, if the home team wins the first game, what's the probability the home team also wins the next 2 games? Next 2 home games. Well, what's the probability of winning a home game? 5/9. And remember, it's independent, so there's no memory. So 5/9 times 5/9. So in this case, A is 5/9 squared. All right, number 47. A chess master wins 80% of her games, loses 5%, and draws the rest. If she receives 1 point for a win, half point for a draw, and no point for a loss, what's the probability of the sampling distribution of X of the points scored in 2 independent games? If you have to do anytime you do something twice, it really is helpful to set up a sample space. And this is a complicated one, to be honest with you. So the probability of getting no points is 0 on the first game. And I mean, not the probability, you can get 0 points on the first game and 0 points on the second game. You could get 0 points on the first game and draw, which would be a half a point. Or you could get 0 and 1. On the next, you could get a on the first game, you could get half a point and 0, half a point and half a point, half a point and 1. Or you can get 1 point on the first game, 0, 1 point, a half, and 1 point and 1. But these all have different probabilities. The probability of her losing a game is 5% or 0.05. And this is also 0.05. Well, 0.05 times 0.05 is what is that? 0.05 times 0.05 is 0.0025. All right, so that's that 0.0025. And that's the probability of getting 0 points. Probability of 0 points is that. But we could also get just a half a point. Well, how does that happen? A half a point would be 0.5 on this one. And this is 80, this is 5. So the probability of a draw is 0.15. So this is 0.15. And this is going to be 0.15. And this is 0.5. 0.05, excuse me, not 0.5, but 0.05. So 0.15 times 0.05 plus 0.05 times 0.15 is 0.015. So the probability she gets a half a point. So this is the probability of 0 points. This is the probability of a half a point is 0.015. And I'm not going to do the rest of them. I am going to do the very last one. The probability that she wins both games, the probability of winning a game is 0.8. The probability of winning the second game is 0.8. And 0.8 times 0.8 is 0.64. And sure enough, this is the probability that she would win both games and get 2 points. So 47 is B. All right, number 48. The appraised values of houses in a city have a mean of 125,000 with a standard deviation of 23,000. Because of new teachers' contract, the school district needs an extra 10% in funds compared to the previous year. To raise this additional money, the city instructs the assessment office to raise all appraised values by $5,000. So they're taking the mean and adding $5,000. You're taking the standard deviation and adding $5,000. And you should be saying to yourself, wait a second, you can't add a constant to standard deviation. So our standard deviation was 23,000. And so they want to go 23,000 plus 5,000. That's the trick that they want you to fall into, but you can't add a constant. So our standard deviation does not change. All right. Spread does not change when you add a constant. The measures of center will, but not the measures of spread. Suppose X and Y are random variables with a mean of 32 and a standard deviation of 5. Mean of Y is 44 with a standard deviation of 12. Given that X and Y are independent, they have to be independent in order to add standard deviations. What are the mean and standard deviation of X plus Y? Well, the means you can add directly. So the mean is going to be 32 plus 44, and that'll give you 76. Well, that gets rid of D. All right. With the standard deviation, we can't add directly. We have to square them, sum them, and take the square root. So 5 squared plus 12 squared, and take the square root of that. So 5 squared plus 12 squared. And then I'm going to raise that to the half power is 13. So my standard deviation is 13. So 76 and 13, my answer choice is B. Number 50, suppose X and Y are independent random variables with expected value of 37, variance of 5, and etc. What are the expected value and the variance of the random variable of X plus Y? First off, they're independent. All right. So 37 plus 62 equals 99 because you can add expected values or mean because expected value is the mean. So that's 99. So that gets rid of D. Variance has already been squared, and we can add variances. We can't subtract them, but we can add them. So in this case, our variance was 5 and the other variance was 12. So 5 plus 12 equals 17. If they had asked us for the standard deviation, we'd have to take the square root of it. So in this case, our answer choice is C. All right. This concludes this video. I appreciate you watching and hope to see you on the next one.